the mean value theorem. So this time we want to talk about the mean value theorem. The mean value theorem is a little bit similar to Rolle's theorem, but the big difference is the Rolle's theorem is we are finding turning point area, which means we have defined that their tangent line slope equal to 0. But the mean value theorem case, we are finding the parallel line between tangent line and secant line here. Okay, then let's read that theorem first. If f is continuous on the closed interval a and b and differentiable on the open interval a and b, then there exists a number c in a, b such that f prime c equal to fb minus fa over b minus a. So when you look at here, so this part indicate tangent line slope. And that's the secant line slope. So to understand better, let's draw the maybe one random graph and then I'm going to explain more. Okay, so let's say I'm going to draw the one graph looks like this and then select maybe A here, then that will be our FA, then B, then this become FB here. Now I'm gonna connect these 2 points and make a line. Then based on this, we can find the secant line slope, M. So M equal to FB minus FA over B minus A, right? Okay, then now I'm gonna continue to draw some random lines besides passing A and B, but they are parallel to this line. Then we can generate many different cases, like this, maybe this. There's so many here, but among these, there are one line passing exactly 1 point, something like this. So then this x will become c, and that will be fc. So this line is tangent line of this curve, and that slope is equal to the secant line slope here. Okay, then how to define tangent line slope? Yes, we are doing derivative, right? So I'm gonna find out derivative. So prime c here. Then f prime c, that's the tangent line slope. And then there will be our secant line slope here. So we are finding particular c value where that slope, tangent line slope, is equal to secant line slope basically. So let's look at one example and talk about a little more detail. So finding a tangent line. So given fx equal to 5 minus 4 over x, find all value of c in the open interval 1 and 4 such that f prime c equal to f4 minus f1 over 4 minus 1. Okay. Again, so this part is tangent line slope case. This is our secant line slope. So now the first step is we can find secant line slope. Okay, using given information. Therefore, we need to find f4 and then f1 first. So f4 becomes 5 minus 4 over 4 equal to 5 minus 1 equal to 4. Now f1 then 5 minus 4 over 1, that equal to 5 minus 4 equal to 1. Therefore, secant line slope m becomes 4 minus 1 over 4 minus 1 equal to 3 over 3 equal to 1. Now, we are finding the x value, where their tangent line slope become 1. So let's find the derivative of this function. So to do so, I'm gonna rewrite fx equal to 5 minus 4 over x because that's easier to see, and this means fx equal to 5 minus 4x negative 1. Okay, so let's start with derivative. Then f prime x equal to negative 4 times negative 1 x negative 2, right? Then this become f prime x equal to 4 over x squared. Now we are setting this equal to 1 basically. Okay, then now I'm gonna set up here. Then 4 over x squared equal to 1. So which means I can rewrite that x squared equal to 4. So x equal to plus and minus 2. Okay, it means the at x equals 2 and then minus 2, their slope become 1. But we need to double check which x value belongs to the interval. So when we look at here, interval was 1 and 4, right? So even though we got x equals 2 or x equal negative 2, this one is not belongs to that given interval. So unfortunately, we have to eliminate that. So we found at x equals 2, we have tangent line slope become 1 basically. That's the answer for this problem. So let's do one more problem. So this time fx equal to x plus 1 over x, and given interval is negative 1 and 2. Okay. So the same thing, we are finding f prime c that equal to f2 minus f negative 1 over 2 minus negative 1 this case. Okay. So what should we do first? Yes, we have to find f2 and f negative 1. So f2 equal to 2 plus 1 over 2, therefore 3 over 2. Now f negative 1 become negative 1 plus 1 over negative 1, so become 0. Okay, so the secant line slope m becomes 3 over 2 minus 0 over 2 minus negative 1, which means 3 over 2 over 3. Therefore, this become 3 over 6 equal to 1 over 2 basically. Okay, so we found secant line slope become 1 over 2. Now we are finding tangent line slope also 1 over 2. Okay, then how can we do that? Yes, we are derivative this one. Okay, so as you see, this is the fraction form. Now I'm gonna set up the top and bottom setup. So t equal to x plus 1 and b equal to x and t prime 1 and b prime 1. Therefore, f prime x become this direction first. So x minus 1 times x plus 1 over x squared. Then this becomes f prime x equal to x minus 1 over x squared. As you see, these two canceled out. Therefore, we have f prime x equal to negative 1 over x squared. Okay, now we want to find out the slope equal to 1 over 2, right? So I'm doing cross multiply. then this becomes x squared equal to -2. Okay, now we are doing square root both sides, then x equal to plus and minus I root 2. So as you see, this is not real x value, therefore this scenario, there's no such x value has the tangent line slope equal to 1/2. That will be the answer for this problem.